Okay, so Colorado beetles is a pest that can cause major damage on potato crops. For a certain Colorado beetle, the amount of oxygen it consumes each day increases as the temperature increases shown in the following table. So this is our temperatures in Celsius, and this is the milliliters consumed by this beetle, the amount of oxygen. Okay, here's the scatter plot. Okay, the temperature is our x in this case, and the oxygen consumed is our y variable. It says find the equation of the regression line y on x. Okay, so y on x tells you all right, so for us to do the y on x, that's going to allow us to estimate the oxygen consumption given the temperature. Okay, so I'm going to make my x values L1 and my y values L2. So when I put these into my calculator, this is going to be L1 and this is going to be L2. All right, so that's what I did right here. And so if I go stat, I already got those put in. So then I'm going to go calculate. Number 4, and they're already set up. X is L1, Y is L2. Okay, I'm going to put the regression equation in Y1. So the variable, function, Y1. And then I'm going to calculate it. Okay, and then there are all my values. Okay, so my slope is 15.5. My y-intercept is -80. Okay, now, for us to graph this, so there's our equation. And then if I did it in Desmos, okay, it's supposed to be a 15. Yep. 15. All right, and for me to do the y on x equation, so y on x, okay, this, I'm going to type in, this is, let's see, up here, okay, y1, and this is x1, and you can see you get the same thing. And there's going to be the line. Okay. So the next part says the mean point has the coordinates 20 to 30. So what that's telling you is the average of the temperatures is 20 and the average of the oxygen consumed is 230. So if I added these 5 up and divided by 5, I'd get 230. If I added these 5 up and divided by 5, I'd get 20. Then it says draw the regression line of y on x, that's this line, on our plot. Well, we know that it has to go, this is, the regression line must pass through that point. So when we draw that, I marked on here where 20 to 30 was. It turned out to be one of the points. The line that I draw has to go through that point. Okay, now to get the y-intercept, so I know one point's got to be that. Now, -80 is my y-intercept. Well, I can estimate where that is. This would be negative 20, 40, 60, 80. So there's negative 80. So I know my graph's got to go through this point and this point. So that's how I can draw the line of best fit. If I wanted to see it on my calculator, all right, I already got it stored under Y1, so if I just do zoom stat, and there we go. Okay, on Desmos, looks a little different because of the scale. Okay, but there's our graph. The scale is just different. That's why it looks so much steeper. Okay, if I changed, whoops, zoom out. The Y scale, if I made it look like the one on your calculator, the Y axis on your calculator goes out to, or on the picture, goes out to 40. So now it looks more like your drawing. In order to estimate the amount of oxygen consumed, this regression line is considered reliable for the temperatures X such that X is between A and B. Write down the values of A and B. Well, in order for it to be accurate, we want to interpolate. All right, and so if we're going to interpolate, we've got to stay within the domain of the data. Okay, so any prediction that we make that is between 20 and then, let's see, our largest X value was 30. So anything between 20 and 30 would be an accurate, a really reliable prediction. Anything outside of that, then we start extrapolating, and that's not nearly as accurate. So anything in here is an interpolation, which is better. Okay, so my values of A and B would be 10 and 30.